Alrighty, so today we're going to continue on talking about domain and range. So remember that these are different ways that we are describing graphs, right? So talking about what data is possible in the x values and the y values. So when we say the word domain, what we're talking about are the x values. And when we say range, we're talking about the y values. It's important to distinguish between those two because if you flip them, your graph is going to look completely different. So last day we showed you some of those point graphs. So ones like this, where when we're writing the domain and range, it's going to be like a list of numbers, right? But remember that not all graphs look like this, right? Sometimes we get graphs like this. And when we have a graph like that, remember, this is called discrete, and this is called continuous. So with a continuous graph, there isn't specific points that are possible. All of the data along that line is possible. And so when that becomes the case, the graph is continuous. Right? So when our graph is continuous, it's made up of an infinite amount of points. So we can't just list them. Instead, we have to write it as an interval. And when we're writing that interval, for domain, which remember is our x values, we're going to be going from left to right. Because remember, when we're writing these intervals, we're always going to go from smallest to biggest. So kind of similar with the y, we're still going to go from smallest to biggest, but this time that's going to be from the bottom of the graph to the top of the graph. We're going to use interval notation. So interval notation, remember, looks like this. And then we have a number less than sometimes equal to x, sometimes equal to, and then another number. And we can do the same thing with the y. So this is kind of like one of those graphs that we were looking at last day, right? We've got those two endpoints. So when we're doing that, we're going to start for our domain. What's the furthest left I can go? And then what's the furthest right I can go? And we turn that into a interval, right? So for domain, the smallest point I can have is 1, 2, 3, 4, 5, 6, 7, so -7. And because that's a solid point, that can also be equal to. And on the other side, I've got 1, 2, 3, 4, 5. And because that's an open point, that means that point is not on my graph. And so it's not equal to, right? That would be our interval. And for our range, now I'm using two colors, so it's a little bit easier to distinguish between what I'm talking about. So my lowest point there is going to be this one here. So if I go 1, 2, 3, that's going to be -3. Now remember, when I'm talking about range, I'm talking about y, so I'm counting on the y-axis. And once again, that's a filled-in point, so that's going to be equal to. Just adding in my interval notation here. And on my wider end there, I'm going to go 1. And because that's open, it's not going to get a line. Right, so those are the intervals that we were talking about last day. I threw this example in because it looks similar, but it's a little bit different this time. So with domain, once again, we've got two endpoints, right? So we hit here, and we hit here. So when I draw that, my domain, 1, 2, 3, 4, 5, 6, and open point, so no line underneath. And for my other side, 1, 2, 3, 4, 5, 6, 7. Solid point, so I'm going to have another underneath. Okay, so now I'm going to do the range. Remember, range is going to be the lowest point to the highest point. Now, if I look, I'm going up and up and up, and I'm looking for a spot that it meets. Notice that this line actually only hits for range at a single point. So it's not really an interval when it comes to range, because none of these values are going to work, and none of these values are going to work. There's only one y value that works in this case. So we can show that by saying for range, y is going to always be equal to 2. Right? None of my other values work. So I can't use a interval in this case. And so that's something to be aware of. And that could happen on my x values too, right? If I had a line like this red one, that's the only x value that's going to work. So x would have to be equal to that value. So pay attention to that because that might show up again as we go. Okay, so now we're going to start to introduce a graph that looks a little bit different. So just like before, we're going to start with domain. So I'm going to start at this left and move over until I hit, so there's my lowest point on my graph. And then I'm going to continue and I'm looking for the highest point on my graph. Notice that by the end of the graph, by the time my line ends, it's not a dot this time. Instead, it's an arrow. What an arrow means when it comes to graphing is that the line continues in the direction forever. So it's never going to stop. So in reality, the end of the graph is here, but this line's actually going to continue on forever. And it's going to actually keep going until it goes off my page. And then it's going to keep going, and it's never going to stop. So how can I represent that? How can I show that my line never ends? What's the biggest possible number that exists in the whole world? The number that we use to mean forever or like non-stop, a number that you will never be able to reach, is infinity. And there's actually two infinities. So if I'm moving in the positive direction, infinity is the biggest possible number that you could ever reach. And if I'm moving in the negative direction, negative infinity is going to be the smallest number I could ever reach. So here, when I'm talking about domain, on this end, I do have a point, right? My graph, my line hits at 0. And it's a dot, so that's going to be part of it. But on my other end, I don't actually have a number to stop at. So the number that I use to show that is infinity. So here my x values can go from 0 to infinity. The 0 is the smallest value, but they can continue forever the other way. Now what about for my range here? I'm just going to erase this red so you can see a little better here. So I'm going to start at the bottom and I'm moving up. So here's where I hit that line, right? And I'm trying to make a sandwich, so I'm going to keep going up and I'm looking for the spot where it ends. Well, once again, that spot is an arrow. And what does that arrow mean? That line's going to continue forever. So what number can I use to show that I don't have an endpoint? Well, that number is going to be infinity. So when I'm writing my range, my smallest point was 0, and it's a dot, so it's going to be equal to, oops. And because it goes on forever, the biggest value there is going to be that infinity. So let's try that here. So once again, we're going to go for domain. So I'm starting at the bottom and I'm looking for the smallest value. So what do we notice on that end? One, it's not a dot, it's an arrow. So what does that arrow mean? That line is going to continue forever and it's going to continue in the negative direction. So when it comes to writing my domain here, negative infinity is my smallest point because that's going to continue forever in the negative direction. And then what about my highest point? Well, if I keep going to the left, we have another arrow. So it's also going to continue forever in the positive direction. So how do I show that number? Once again with infinity. So this shows me that my graph can go all the way from negative infinity to positive infinity. And there's no x values that are not possible for this graph. So for our range, we're going to look at the up and down. So by starting at the bottom, once again, we have that negative infinity, right? That arrow. And as I continue up, we've got that positive infinity, that arrow. So when you see arrows, we're dealing with numbers that are too big, right? They're going off our graph. So this time we're going to look at parabolas, so graphs that have different curves and shapes. So domain, right? We're starting left to right, right? We're going this way, left to right. So as I'm going in, I'm looking for my endpoint. So my endpoint is an arrow. What does that tell me? That there is no endpoint. This line is going to continue forever, right? It's going to continue off my page, and then it's going to continue even further. So what that means is there is no limit, right? Negative infinity is my limit. Oops. And I'm going to continue, and I'm looking for the other edge. Well, once again, it's an arrow. So that means that that line doesn't stop. There is no, let's say, like bread on that sandwich, right? It's open. So it's going to go to infinity. And for my range, I'm going to start at the bottom and I'm move up, and I'm looking for that first spot when that graph hits. Now this time, it's not an arrow, it's a point. So for the range for this graph, the smallest value is going to be 0. And because it's a point, right, it's going through that, we're putting that equal sign down. Now if I continue up, I'm looking for the highest point. Now notice the highest point on my graph is not a point, it's an arrow. So what that arrow tells me is that line continues forever. So infinity is how I show that that's going to go on forever. And if I flip my graph, similar but different, right? We're still following the same steps. I'm going from left to right, and I'm looking for the point. It's an arrow that tells me that that's going to continue forever. So we use a negative infinity to show that. And as I continue on the other side, I also have an arrow. So that means that there's also no limit on that side of my graph. Now for range, we're going to start at the bottom and move up. Now the lowest point that we see on this graph is arrows. So that means that there is no lowest limit, right? That graph will continue down forever. So we show that, with the negative infinity. And as I move up, I shouldn't draw that line on yet because I need to check and see if they're open or closed. I'm going to move up, up, up until I hit the highest point on my graph. Now this time there is a limit, right? It's not an arrow, it's a point. And that point is solid, so I am going to need that number underneath. And it's 8. So 8 is the highest point on that graph. Oh, those are all my examples. So my advice to you as you work on these this week is to really use those sandwiches, right? Draw your lines and note whether your endpoints are arrows or points. Because a point you can use a number for, but an arrow continues forever, right? And notice what direction your arrows are moving in, because that's going to make a big difference. There is no IXL work this week, so you're just going to be doing an assignment and then a quiz for this week. So keep your eyes on the planner, which is where that assignment's going to show up.